In this video, you will learn reaction yields. We will learn about theoretical yield and actual yield. The amount of product that may be produced by a reaction as calculated per the stoichiometry of an appropriate balanced chemical equation is called the theoretical yield of the reaction. In other words, theoretical yield is the calculated yield. On the other hand, the amount of product obtained is called the actual yield. In other words, that will be the experimental yield. Let's look at an example. Well, before that, so we give a new definition. Percent yield, that is the actual yield divided by the theoretical yield and then multiplied by 100%. Okay, let's look at an example. Upon reaction of 1.274 grams of copper sulfate with excess amount of zinc metal, 0.392 grams of copper metal was obtained according to the following balanced equation. Okay, so let's look at it. How much do we get over here? Over here it says 1.274 grams of the copper sulfate. Can I just use the gram to calculate for the gram? No, because the balanced equation, the coefficient is the ratios in moles. That's why we have to convert 1.274 grams of copper sulfate into number of moles. How do I do that? Let's try. Okay, so I have 1.274 gram. And for copper sulfate, let me write it over here. 1.274 gram for copper sulfate. The molecular weight, it is 159.62 grams per mole. If we do that, then we are going to get how many moles of copper sulfate. Now, let's look at how many moles of copper solid that we expect to yield as a product. The ratio, it is 1 to 1. And by the way, how do we know that copper sulfate is the limiting reactant here? Because it says with excess amount of zinc metal. That means we have infinite amount of zinc over here. So zinc will not be the limiting reactant. All right, so if we have that many moles of copper sulfate, how many moles of copper do we get? It's about the same amount of moles. But how many grams? Okay, so we need to multiply by the atomic weight of copper, that is 63.55 gram per mole. If you do that, it will end up with this gram will cancel with this gram, this mole will cancel with this mole, and I did my calculation. I got 0.5072 gram. Okay, so this is called a theoretical yield because based on the calculation, that's what I would expect. However, during the experiment, only 0.392 grams were obtained. That means we did not get 100%. 100% will be 0.5072. Where did the error coming from? Well, different places. Maybe stick to the beaker. Maybe it did not completely reacted. And sometimes maybe it spilled out a little bit. Regardless of what happened, the yield, the percent yield will be equal to the actual amount that we obtained from the experiment, that is 0.392. If you divide it by the theoretical yield, 0.5072, and then multiply by 100%. So that is the percent yield. Let's try. It is 0.392 divided by 0.5072 and multiply 100%, so it's about 77.3%. 77.3%. Okay. Let's work on an example. A student isolated 25 grams of a compound following a procedure that would theoretically yield 81 grams. What's his percent yield? So supposingly, theoretically, that means by calculation, we expect to have 81 grams if 100% yield out. Okay, but actually, his experiment, he only get 25%. So how do we get the percent yield? It will be equal to the actual yield. So percent yield will be equal to the actual yield. In this case, what is the actual yield? The actual yield is 25 grams. Actual yield divided by the theoretical yield. Theoretical yield. That will be equal to 25 divided by 81. Well, multiply by 100%. That will be equal to 25 divided by 81. I get 30.9. So roughly equal to 30.9%, which is very low. Okay, let's try another example. Okay, a sample of 0.53 grams of carbon dioxide was obtained by heating 1.31 gram of calcium carbonate. What is the percent yield for this reaction? Okay, so let's see what we get. It says carbon dioxide, so this one, we get 0.53 gram. Okay, so that is from heating this part, we get 1.31 gram. And by the way, before we look at anything, let's check if the equation is balanced. On the left side, I have 1 calcium. On the right side, I have 1 calcium, so that is good. Carbon, 1 on the left side and 1 on the right side, that's good. Oxygen, I have 3 on the left side and I have also 3. Okay, so the equation is balanced. Well, in this case, that's good. We don't have to determine what the limiting reactant is because we only have 1 reactant. Okay, so can we look at it, just say, oh, it's a 1-to-1 ratio. That means we should expect to yield 1.31 grams over here? The answer is no, you cannot do that. The coefficient ratio, it only refers to the mole ratio, not in grams. Okay, so we have to convert everything into moles. Okay, so what we need to do is we need to calculate the molecular weight for calcium carbonate. So calcium, it is 40.08, carbon it is 12.01, and oxygen is 16.00, but we have 3 of them, so we multiply by 3 over here. So 40.08 plus 12.01 plus 16.00 times 3. I get 100.09. 100.09. The unit will be grams per mole. Okay, so what's next? 1.31 gram, that is equal to how many moles? I'm going to put the mole on top. It will be 100.09 gram per mole. So what I get is 1.31 and then divided by whatever we have. So I get 0.0131 mole. Okay, let me just repeat what I just did. Over here, I get 1.31 grams of calcium carbonate, but I cannot use the grams to do the calculation. I have to convert the grams into how many moles. Okay, to do that, I first need to find out the molecular weight or formula weight for the calcium carbonate. After that, I use the gram divided by the molecular weight, and then I get the number of moles. Now, we know that the number of moles is here, but how do we get the number of grams of carbon dioxide? So we have to see how many moles first, since it's a 1-to-1 ratio. So how many moles of the carbon dioxide do I expect? Well, 1-to-1 ratio, that means it's the same thing. So we should expect to have 0.0131 mole. Okay, that many moles, that means how many grams? Okay, now we have to do the molecular weight again. So over here it will be 12.01, it will be 16.00 carbon dioxide, so multiply by 2. So I will have 32 plus, I have 44.01 grams per mole. Okay, so that means that many moles multiplied by 44.01 gram per mole. What I get is, I should expect to have 0.576. So this one is called a theoretical yield because everything is based on the calculation. That means if 100% happened, the reaction happened, I would expect to have 0.576 gram. But from the experiment, I only get 0.53 gram. Okay, so what is the percent yield? Percent yield, that is equal to the actual yield, in this case is 0.53, divided by 0.576. And multiplied by 100%. 0.53 divided by, that one is about 92%. So roughly equal to 92%, which is a very high yield.